Hello, happy snow day. That's why we are in our pajamas and on a video call because it's kind of dangerous to exist outside in Indiana today. This is the first 2022 update on the JAWS project. I now have a new friend with me. Hunter, if you'd like to introduce yourself.
Hi, my name is Hunter Velazquez. I am a mechanical engineering student here at Purdue. I have a lot of seemingly relevant experience with control systems and robotics. Yeah, I've been here giving that experience and helping design the actual mechanisms with which we plan to incorporate JAWS and how we plan to mechanize that.
Yeah, so basically, I figured out last semester that this is not something I should be doing by myself with the very little relevant experience that I do have. So I reached out to my pal Hunter here, and he was game to come aboard and help. So he's been helping since, I don't know, halfway through last semester, I want to say. About then. Last I put up a video, it was around Halloween, and things were just starting to get put into place with getting a lab space and, of course, getting my new lab partner. From there, we started working together and started working on the winch design that I had originally created, actually getting the winch to work and seeing if the winch would be a feasible system to power our chompy skulls. And then Hunter has this wonderful, I the the bed. I don't quite know how to describe what it
I
is. It's just the
developed
bed.
a robotic control system for a device used to mechanize like furniture. It's currently hooked up to a bed. Control system for that would be something very similar to what we would use to power a winch. So we just hooked it up to that and eventually realized that the winch is not a viable option for variable pressure control.
In other words, the circuits fried themselves, and we realized that we could not continue to fry circuitry. So, the end of last semester, we started brainstorming alternatives to the winch, and that kind of brings us to where we are now. So, we're looking at a pneumatic system to power jaws now. Instead of using the tension force of the winch, we would instead be using compression force by a pneumatic piston. Hunter's been doing some research into that, and one of the big hurdles that we've been trying to jump most recently, besides just figuring out what we need to get for a pneumatic system, is also what are we going to be using for the actual skull itself? Because Fido is plastic. Fido is a polyurethane resin, which is not strong enough to do what we need it to do. But also getting an actual skull, having sat out for a while, it would have dried out and lost a lot of its tensile strength. It also can't really do what we need it to do. So we've been talking to some people at the American Foundry Society, which is a club here at Purdue, and they do all sorts of foundry work, including sandcasting and also some other method of casting that they mentioned briefly to essentially make a metal version of Fido's teeth. So we can hopefully hook that up to a pneumatic system. Is it a perfect solution? No, but it's probably the best we can get with our budget and our resources. That's our best alternative for now, and we have a meeting with them soon. But yeah, in terms of plans for this semester, Hunter, do you have any contributions in that regard, or like thoughts on what we're doing, scientific vocabulary, all the jazz?
I suppose the hope that we get the metallic skull just to be able to bite down on bones with something that the bones won't break themselves. So that's kind of what we're going for there. Skull's effect on the bone, not vice versa. So that'll be helpful. Been in the works of developing a pneumatic system to incorporate here, but I'm working with some previous colleagues of mine with relevant experience as to how we could best automate that through the use of electronics. Should be relatively automatic given the right tools. And so I'm currently researching how to implement that. And once we have a viable like circuit plan, the actual construction of a preliminary prototype where we are actuating pneumatic pistons, fully compressed pneumatic cylinders to give a total of however many psi we plan to output through the jaws, and then subsequently after that, once we have a first prototype pneumatic control, then hooking that up to the current frame for jaws and connecting up our surrogate skull, our jaws 1.0, if you will.
So We do also realize that this is a very ambitious timeline because the first conference that JAWS will be featured at is at the end of March, and it is currently February 3rd. So there's a list of deliverables that we definitely think we can accomplish and a list of deliverables that we would love to accomplish if we don't run into any setbacks. In terms of what we absolutely definitely can deliver for the SAA conference and the OER conference this spring, we will definitely have a CAD model, a computer-aided design model, basically 3D in your computer of what we would want to build JAWS to be. We'll definitely have something modeled if we can't actually build. And that's a predecessor to building anyway. I think we can also confidently say we would have at least a bill of materials of what we would use to build JAWS. Hunter, feel free to agree or disagree there. A lot of the issues that we think we will run into in terms of actually building it come from, supply issues. There's been a lot of that due to the pandemic and now weather and just like availability of items and then also shipping times and things like that. CAD model, definitely for sure. Bill of materials, definitely for sure. Anything else that you think we can definitely deliver no matter what, Hunter?
I think it's pretty good. Yeah, okay. There are some things that we would like to hit, but those are things that are not contingent on getting supplies from other places. I am working with a supplier out of Indianapolis, so hopefully getting supplies shouldn't be that difficult.
So the point being, if we can't actually build it, we will create all of the necessary models and lists of materials. So if you wanted to assemble it, it could be. That's kind of the TLDR here. But if we have the time, if suppliers work out in our favor, if our research goes and everything goes as anticipated, which is, of course, assuming a lot, we would love to actually have something that could clamp onto a bone and leave indents in it. That's the goal, is to have a bone that we can hold up and be like, look, it's got pockmarks in it. We've got some bone surface modifications. I don't think we have the time to calibrate for accuracy, just with the time constraints we have and having to redesign most of the system due to circuitry issues last semester. We'll at least have something that can hopefully do the task, a lot of variables pending. Any other thoughts on that, Hunter, or did I cover all those bases?
Just in terms of what we mean by not necessarily having the time to calibrate for accuracy, there's a lot of variables that go into what exactly makes up the bite force of a gray wolf. And so when we say that we don't have time to calibrate for that, it's in the sense that we know that we can get the system to output the bite force of a gray wolf. It's just paring that down to figuring out what exactly the PSI input for the system needs to be in order to get that very specific output. And that would just have to be calibrated over time through.
So JAWS now in its final form, I know when I initially set out to make this project, it was to basically be able to run some statistics over the bite marks and have them pretty much match already existing wolf marks. Now, from an engineering standpoint, as the engineers on this project, we feel that it is our job to engineer and make the device that is capable of executing such a task. We don't necessarily have the research background or frankly time before conferences to calibrate it accurately enough to get those accurate marks I was initially hoping for. So the goal is to make a device that can bite things, and whoever decides to use in the future can then go and run those calibration trials and figure out what PSIs they need to use, et cetera, et cetera.
But in theory, that could be used for any animal bite.
Yeah. We're hoping to design the system so that goals can be interchanged. We're just using a gray wolf because that's what we've been working with, and, one step at a time. Is there anything else that we've already done to get started on that this semester? We've reached out to the Foundry Society. You've been emailing people like crazy. I think we kind of covered all our bases. Is there anything else you want to add? Since I don't know what you said. Good. All right. Well, I think that'll be it for this then. So we'll hopefully have another report for you in the next couple of weeks once we start to get more research and hopefully some modeling done. So thanks for watching.